The entity relationship, or ER data model, has existed for over 35 years. It is well suited to data modeling for use with databases because it is fairly abstract and is easy to discuss and explain. ER models are readily translated to relations. ER models, also called an ER schema, represented by ER diagrams. ER modeling is based on two concepts: entities, defined as tables that hold specific information, data; relationships, defined as the associations or interactions between entities. Here's an example of how these two concepts might be combined in an ER data model. Professor Ba, entity, teaches, relationship, the database systems course, entity. For the rest of this chapter, we will use a sample database called the company database to illustrate the concepts of the ER model. This database contains information about employees, departments, and projects. Important points to note include: there are several departments in the company. Each department has a unique identification, a name, location of the office, and a particular employee who manages the department. A department controls a number of projects, each of which has a unique name, a unique number, and a budget. Each employee has a name, identification number, address, salary, and birth date. An employee is assigned to one department, but can join in several projects. We need to record the start date of the employee in each project. We also need to know the direct supervisor of each employee. We want to keep track of the dependents for each employee. Each dependent has a name, birth date, and relationship with the employee. Entity, entity set, and entity type. An entity is an object in the real world with an independent existence that can be differentiated from other objects. An entity might be an object with physical existence, example, a lecturer, a student, a car, or an object with conceptual existence, example, a course, a job, a position. Entities can be classified based on their strength. An entity is considered weak if its tables are existence dependent. That is, it cannot exist without the relationship with another entity. Its primary key is derived from the primary key of the parent entity. The spouse table in the company database is a weak entity because its primary key is dependent on the employee table. Without a corresponding employee record, the spouse record would not exist. An entity is considered strong if it can exist apart from all of its related entities. Kernels are strong entities. A table without a foreign key or a table that contains a foreign key that can contain nulls is a strong entity. Another term to know is entity type, which defines a collection of similar entities. An entity set is a collection of entities of an entity type at a particular point of time. In an entity relationship diagram, or ERD, an entity type is represented by a name in a box. Existence dependency. An entity's existence is dependent on the existence of the related entity. It is existence dependent if it has a mandatory foreign key, that is, a foreign key attribute that cannot be null. For example, in the company database, a spouse entity is existence dependent on the employee entity. Kinds of entities. You should also be familiar with different kinds of entities, including independent entities, dependent entities, and characteristic entities. These are described as follows. Independent entities, also referred to as kernels, are the backbone of the database. They are what other tables are based on. Kernels have the following characteristics. They are the building blocks of a database. The primary key may be simple or composite. The primary key is not a foreign key. They do not depend on another entity for their existence. Dependent entities, also referred to as derived entities, depend on other tables for their meaning. These entities have the following characteristics. Dependent entities are used to connect two kernels together. They are said to be existence-dependent on two or more tables. Many relationships become associative tables with at least two foreign keys. They may contain other attributes. The foreign key identifies each associated table. There are three options for the primary key. Use a composite of foreign keys of associated tables if unique. Use a composite of foreign keys and a qualifying column. Create a new simple primary key. Characteristic entities provide more information about another table. These entities have the following characteristics. They represent multi-valued attributes. They describe other entities. They typically have a one-to-many relationship. The foreign key is used to further identify the characterized table. Options for primary key are as follows. Use a composite of foreign key plus a qualifying column. Create a new simple primary key. In the company database, these might include employee, like EID, name, address, age, salary. EID is the simple primary key. Employee phone, EID phone. EID is part of a composite primary key. Here, EID is also a foreign key. Attributes. Each entity is described by a set of attributes. Example, employee equals name, address, birth date, age, salary. Each attribute has a name and is associated with an entity and a domain of legal values. However, the information about attribute domain is not presented on the ERD. Types of keys. There are several types of keys. These are described as follows. Candidate key. A candidate key is a simple or composite key that is unique and minimal. It is unique because no two rows in a table may have the same value at any time. It is minimal because every column is necessary in order to attain uniqueness. From our company database example, if the entity is employee, EID, first name, last name, SIN, address, phone, birth date, salary, department ID. Possible candidate keys are EID, SIN, first name and last name, assuming there is no one else in the company with the same name. Last name and department ID, assuming two people with the same last name don't work in the same department. Composite key. A composite key is composed of two or more attributes, but it must be minimal. Using the example from the candidate key section, possible composite keys are first name and last name, assuming there is no one else in the company with the same name. Last name and department ID, assuming two people with the same last name don't work in the same department. Primary key. The primary key is a candidate key that is selected by the database designer to be used as an identifying mechanism for the whole entity set. It must uniquely identify tuples in a table and not be null. The primary key is indicated in the ER model by underlining the attribute. A candidate key is selected by the designer to uniquely identify tuples in a table. It must not be null. A key is chosen by the database designer to be used as an identifying mechanism for the whole entity set. This is referred to as the primary key. This key is indicated by underlining the attribute in the ER model. In the following example, EID is the primary key. Employee, EID, first name, last name, SIN, address, phone, birth date, salary, department ID. Secondary key. A secondary key is an attribute used strictly for retrieval purposes. Can be composite. For example, phone and last name. Alternate key. Alternate keys are all candidate keys not chosen as the primary key. Foreign key. A foreign key, or FK, is an attribute in a table that references the primary key in another table, or It can be null. Both foreign and primary keys must be of the same data type. Employee, EID, first name, last name, SIN, address, phone, birth date, salary, department ID. Nulls. A null is a special symbol, independent of data type, which means either unknown or inapplicable. It does not mean zero or blank. Features of null include no data entry, not permitted in the primary key, should be avoided in other attributes, can represent an unknown attribute value, a known but missing attribute value, a not applicable condition. Can create problems when functions such as count, average, and sum are used. Can create logical problems when relational tables are linked. Note, the result of a comparison operation is null when either argument is null. The result of an arithmetic operation is null when either argument is null, except functions that ignore nulls.